Thank you, everyone. It's so great to be with all these tree people that I can't really see well because of the lights, but thank you for being here. And the thought came to me, we recognize the ancestral peoples that lived here. We should also recognize the ancestral trees that were here, right? Because there were some beautiful old growth trees on this spot where we're sitting and standing tonight. So we are going to, there I am. We're going to talk about old trees. Thank you for joining me in this book release presentation. All my presentations are different, but tonight I'm going to talk about the brand new book, Nature's Temples, that's added to my collection of other tree and forest books that I've written. So why did I want to write this particular book, Nature's Temples? Well, this is why I wanted to write this book, because we have cut so much of our forest, and you would think that we at some point would have learned that what happened in the past wasn't wise and that we should leave some more of our forest standing, but we keep cutting these forests that are trying to regrow. So these are second growth forests here that I'm sitting and standing by. The one on the left is Maryland, where I live, where I came from yesterday to be here. The one on the right is New Jersey, and these are public forests. And these are trees that have, the original old growth forests were cleared, the trees grew back, but now they're being cut again, these mixed native forests, and they're not going to be the same if we keep doing that. And why does this happen? Well, there's this whole forest industry out there that makes money from the timber and that are educated to make money by managing these forests for only certain species. And on the left, I represented there a forester going into one of these public forests saying, yes, I think, or a private forest, it's time to cut it, we need to cut it. And there I am on the right going like, well, what about the salamanders? What about the snails? What about the fungi? And it's a fascinating time in history because it really does feel strangely like war. And I put that book there. It's by Derek Jensen, and it was written in the 90s, but this is what he's talking about. It's like we're at war with the forest. So right now we have almost these two sides, and I'm not an antagonistic sort of person, but I think it's important that we speak for the forests and recognize what's happening. So the forest industry realizes that the majority of us, when you do the surveys, think we need to keep more of our forests standing and intact. The numbers are like 80 to 90%. So the forest industry realizes that the level of logging we do is unacceptable, and it used to be that it would be the logging just for the income, and then they kind of changed it and said, well, it's for jobs, remember that? The owls versus the loggers. Well, now it's changed, and there's using a lot of terminology like, oh, it's for the health of the forest, and we're just restoring the forest, and we're regenerating the forest, and now the newest one is resiliency. We're doing it for resiliency. And these words all sound so good, and actually it's PR firms that came up with a lot of these terms we're using. And unless people are really educated and know what's happening, this all sounds really good. Yeah, these people studied forests, they know what they're doing, and we're gonna let them do this because it's the right thing. But you have to really get in the weeds, and study it to find out, is this really good or not for the forest? Do we need to manage the forests? So that's why I wrote this book. The big question is it better for the forest to manage it? Does it keep it healthy or not? And so I did dove into the scientific research, and any scientist that studied any comparison of unmanaged forests, so these are old forests, they're untouched, versus human managed forests, what did they find out? So I wanted to answer these questions for myself too, and then share the answers. So first of all, this is the timeline of life on Earth. So this would be like, 3.8 billion years ago, and then we're going up billions of years, when there were only like jellyfish in the sea here, and then only creatures in the sea. And right about this time, we had plants coming onto the land. Before that, there was no life on the land. But 350 million years ago, forests evolved. And they look nothing like our forests now. The species are all different, but the point is that these plant forms grew that were taller than, over our heads. There weren't humans there then, but these forests were very successful then, took over large parts of the earth, and for 350 million years, forests have covered large parts of planet Earth. And look where humans evolved, this other green line, only 4 million years ago. So do you think the forests need us to manage them? From an evolutionary point of view, absolutely not. In fact, they were doing just fine without us. We're the ones that messed them up. So when we look at much more recent history, right? We have the continents and the position that we know of them now. If you picture all the yellow and green as all being green, that was the recent forest cover up until just 5,000 years ago. And then with the agricultural revolution, with the evolution of technology and human culture, we've started whacking away at the forests, and the forests then became a commodity. So yeah, we can use trees. Trees are very useful. Humans have always cut trees and needed trees for shelter and for wood and to clear areas. I'm not against that at all. But when they became a commodity and traded throughout the world, or just burned to be out of the way for agriculture, that's what's happened in the last 5,000 years. And so whoops, I did not mean to do that one, but that's okay. But the green forests, you can see that were left there were the boreal areas and some of the tropical areas that are hard to get to, but we're still cutting them too. Okay, so looking more closely at just the US, this is the original old growth forests in our country in black. These graphs were made in 1925, and yes, there were native peoples living here then, and yes, they did clear some forests, and yes, they did have some agriculture, but from what we can tell, most of the forest was still old growth forest. So it was really only affected on a small scale, the native people. And a lot of folks have exaggerated the effect that the native population had on the forest, saying, oh, it was all burned everywhere, it was big farm fields, but the more recent research that's done by looking at the pollen record shows us that they didn't have as great an impact as some people think. Okay, so with the European settlers coming in, almost immediately the forests became a commodity and then were exported. They were exported to the places that had already cut their forests. So back to Europe or to the island nations that had cut theirs, and for every use we can think of, right? For the sailboats, for the houses, for the railroads, and on and on and on. And by 1920, not much of the old growth is a lot less, and you can see really then the western expansion. It took us a while to get to the western trees, but eventually we did. And to now, we have 1% left in the east and 5% left in the west. And the reason I think we have more left in the west is because the environmental movement kind of woke up and saw what happened in the east. And some people were active and were able to stop some of the cutting that was going on. You know, I'm an Easterner, live in the East. A lot of people in the East think, oh, we saved the redwood forests. And I tell them, no, we cut 98% of the redwood forests, but we've saved a few percent, and that's very special and important. So, global forest area, that's this line here, and you can see it's declining. Global forest cover has been reduced from 46% at that dawn of civilization I was talking about to 31% now. And this is monitored by the UN. Every 5 years they come out with a different, with a report. And every time you look at it, we've lost more forest cover. So we like to think we're waking up. Maybe some of us are, but still, we need to do more. We're losing forest cover. And then this line here is the carbon dioxide level in the atmosphere. There's a relationship there, definitely. And then we're, of course, also pumping the fossil fuels out of the ground. That's why the CO2 levels are going up. The forests are doing a lot to try to bring that down. So the forests absorb about 1/3 of the carbon dioxide from the fossil fuels that we burn. And it's actually fertilizing the forests in a way. They like CO2, they want to suck it up, but we're destroying the forests so they can't keep up with what they're doing. And then, so we're deforesting at the same time. So the old think in forestry thinking was that old growth forests are carbon neutral, trees grow, they store carbon, then they die, they rot away, they release the carbon, and it was kind of equaled out. But what our newer research is showing us is that old growth forests continually accumulate carbon both above and below ground. So the big old trees were thought of as kind of just there, neutral, and it's the young trees that are really sucking up the CO2, and they're really doing the job. But the more we learn, the more we find out that that's not true, that the older forests are very important for carbon storage. So now finally to the book. So this is why I wanted to write this book, to look at the difference between these young managed forests and the older unmanaged forests. So we're going to go pretty quickly. We're going to start at the top here, and then we're going to talk about each of these. We're starting with carbon storage. The older unmanaged forests have higher carbon storage. They sequester, here it is, 39 to 118% more carbon than any of the active management options. So this chart here, which you can't read anything, I know, and these dotted lines, all different colors, these are different cutting plans. Do you want thinning? Do you want shelter wood cutting? Do you want a regeneration harvest? All those forestry terms. Well, no matter what you do and what your interval between cutting is, it can't compare to this line here, which is the unmanaged forest. The natural growth of the forest is always going to store more carbon. So anybody tells you that we have to thin the forest so it can absorb more carbon, you can tell them that's not true. Okay. This research was fascinating to me Because we think, okay, well, things happen to the forest. There's forest fires, and then there's beetles that kill the trees, and the dead trees give off carbon, and the burned trees give off carbon, and the trees that get caught in the storms give off carbon, and all that's true. And this researcher said, okay, let's try to quantify the amount of carbon that's released from all these things. Okay, so here's the darker the red, the more carbon that's given off. So the fires, out west, that's much more of a problem, or the insects, or windstorms. But look what releases most of the carbon, and that's the harvesting. Forest harvesting accounts for 85% of the carbon lost from forests each year. And a lot of that is because there's slash that's left on the ground, immediately decomposes, and that carbon goes into the atmosphere. A lot of this carbon that's stored in the soil gets released into the atmosphere. And then even at the mill, there's a lot of waste there, and those products release carbon as they rot. So, if, again, you can hear we have to, cut for this reason or cut for that reason. Well, this cutting is releasing a lot of carbon into the atmosphere. And the other problem besides the carbon in the atmosphere with cutting these forests, to me, is the biodiversity problem. We're living in the Anthropocene now, where humans are causing this extinction crisis. And these are organisms that have evolved over many, many millions of years, just like the trees. They were around long before humans, most of them, and we're losing them. And one of the reasons is because we're losing forests. So 80% of terrestrial species depend on forests for habitat. So we lose the forest, we lose the habitat, we lose the species. So that's what we're going to talk about now, that moving on down the line. Salamanders, old growth forests, many more salamanders per acre, many more species of salamanders than the second growth or the clear cut. I'm not going to go into the details. They're all in the book if you want to read the science on these. Lichens, same. These little calicoid lichens, these are microscopic lichens. And one of the researchers found, well, in an old growth forest, there's going to be 20 different species of these. In the second growth forest, second growth, of course, is a forest that's been cut and regrown, you'll find 3 to 19 species. In a young forest, 0 to 2 species. So when you cut that old forest and it becomes a young forest, you're losing all those calicoid lichen species. Beetles, many more predaceous ground beetles in the old growth forest. Some insects, such as this looper, only found in old growth forests. So we cut those forests, those organisms are gone. Fungi, more mushroom species in older native forests. And a lot of the reason for that is the rotting wood, but also these mycorrhizal relationships. A lot of the fungi depend on the trees, because the trees are photosynthesizing, they're making sugars, they're sending those sugars down into the roots, and then the roots, that sugar is feeding those fungi in a way, because the fungi can't photosynthesize. They need energy, just like us. We can't photosynthesize, we need energy, we gotta eat something. These mushrooms are getting sugars from the tree, but then in return, the fungi are giving the trees amino acids that the trees can't make on their own. And also fungi have a lot of enzymes that can do things like dissolve the minerals from rocks the trees can't do. And so it's a very symbiotic relationship. So if you like mushrooms, you'll want older tree species. And this is another picture of that same thing with the trees providing sugar and carbon to the fungi, and then the fungi providing water also, I didn't mention, very important. Those mycorrhizal networks can go a long distance and they can actually bring water back to the tree roots. And what we're learning now through Suzanne Simard's research is that the fungi can actually work as a connector and can connect the trees together, and so compounds can actually be moved from tree to tree through the mycorrhizal network. And that's what this diagram is showing. This is from one of her lab papers. The dark green trees are the older ones in this picture. These are all Doug firs. The medium green, medium-sized trees, light green, small trees. And they actually mapped all the connections, mycorrhizal connections between these trees. This is a stylized drawing, of course. But what they found was that the older the tree, the more other trees it was connected to. So one of these old trees over here was connected to 47 other trees in the forest through this mycorrhizal network. So if you say, well, we're just gonna, go in there and thin it out and just take out some of the larger trees, then you're affecting that whole network. And we're just learning about this, right? What else are we gonna learn about? Okay, and then snails. It's interesting, this research about comparing the old unmanaged forest to the managed forest, because first of all, we don't have that many in other parts of the country besides here where you're so blessed with so much old growth, but in other parts there's not that much old growth left, and so it's hard to do this research. You need these study sites. And with the snails, nobody had ever compared the snail biodiversity in the old forest to the younger managed forest, but this one master's research student in Tennessee said, this is the study I want to do, and he found many more snail species in the old growth forest, right? You're detecting a trend here, but then he also found some snails like this little one the size of a grain of rice that's only in the old growth forest. So if we cut that forest, that snail's probably going to disappear. And then the last one in this is herbs, or we could call it herbaceous plants or wildflowers, whatever you want to call them, more of them in the unmanaged old growth forest than in the managed forest. And a lot of these woodland tree species depend on ants to carry their seeds. So they depend on pollinators to pollinate them, and so they depend on an ecosystem to support them. And the forestry, this is a quote from one of these papers, is not conducive to long-term maintenance of herb diversity, the way we manage our forests. So the old growth forests, one of their characteristics is that they do develop these gaps. So one of these big old trees that's taken up a whole lot of space will fall over, and then you have light coming into the forest floor, and that's where you'll see a lot of these light-dependent flowering species. So the forest industry, knowing that some things need light on the forest floor, will say, oh, well, then we have to cut the forest to get light to the forest floor. But then in the process, they're destroying these very plants and the insects and the pollinators that depend on them. Okay, so that's kind of the story of the book of, making that case. And I really did this for the average person who loves trees and forests, feels it in their heart, wants to do something about it, but they don't, they haven't had a million years of schooling like I have and don't have access to all those research papers. So I wanted to put all this in one spot so they could reference it, so they could speak truth to the power, really, so they have the words to share. And often in those terms that I used at first, the resiliency and the health and the sustainability and all that, claims are made by the forest industry without the research to back them up. So if you're ever in this position and someone makes a claim like that, just ask for their research, and look at the paper, and that's what I'm doing. So there's the research, which, as a PhD scientist, I want to be very honest about the research. But then beyond that, what do we do about that? When the research tells me that these older unmanaged forests are so important for the biodiversity and for the atmosphere and everything, we got to take it the next step, right? We got to save them. And so what came to me was, how are we going to save more of these forests? We can't just say, save the old growth. And I thought, well, if we can quantify this, again, the scientist in me, right? Quantify this so that we say, well, we've saved one forest at least in every county that's open to the public, pretty accessible, then no child is going to be too far away from one of these forests. That either, ideally it's old growth now, but if there's no old growth left in a county, we can find an older forest and say from now on, this forest is not going to be cut. So that idea, one forest in each county protected from logging, open to the public, came to me as the old growth forest network. And that means wherever you travel, wherever you end up moving to, there will be one of these protected forests nearby that you can find out about. So I had the idea, I went home and I Googled counties in the United States, and I went, oh my God, when that map came up on the right. There's over 3,000, but then some of the counties are prairie, some are desert, can't support forest growth, but 2/3 of them can. So that's our goal, is to have one protected forest in each of these counties. And then I also knew that I could not do this alone. For one thing, I was going to need some financial support if I was going to drop everything and do this. And even then, I would need people to help me. So I got some people to be on the board. We formed a 501c3, and that was about 10 years ago. And then in each county now, we're trying to get a volunteer county coordinator that can be that person that will look at their county and try to find where these older forests are, try to see if they're protected, and can then suggest to us what forests can go in the network, and we help them. And we have a couple county coordinators here tonight. Will you guys raise your hands? Let's see out there. Right now, we're at 191 forests in 33 states. Yay! So it's Earth Week. We're doing a lot of dedications this week, and we're very close to 200. We're going to hit 200 in May. And if you want to know where any of these forests are, you can go to our website, oldgrowthforest.net, and Christine, my wonderful helper that does our website here, and she keeps all the forests up on there, and we tell you exactly how to get there with directions and when you can visit, and we also tell you if the forest is true old growth or if it's one of our future old growth forests that are protected. And you can also see that we have our donate button there, and this has been all supported by individuals who get it and who care, or by small family foundations. So there's no government support, and people have been very generous in supporting the organization, and so now we're able to expand little by little, and it's not just me anymore. Yay! Thank you, everyone. And I know we have supporters right here in the audience too, so thank you so much. All right, so here's what it looks like here. We got a lot of counties, and a lot of counties. We need more county coordinators. I think Greg here is going to be recruiting tonight. And I have a place where if you're interested and you want to sign up and, you can either sign up to be a county coordinator for one of these counties, or if you want to just nominate a forest, you have a favorite forest somewhere and you think, oh, that would be a great one for the old growth forest,